Hello and welcome to the last part of this series where we are solving quadratic equations via different methods. And so in this last video, I want to show you how to solve the same equation, x squared plus 4x minus 21 equals to 0, but this time via the graphical method. So as you can see, I pulled up Desmos on the left hand side of the screen, and I've graphed x squared plus 4x minus 21. And actually, strictly speaking, what I'm actually graphing is y equals to x squared plus 4x minus 21. That's what I'm graphing over here. So for different values of x, right, when I plug in different values of x, I get different values of y. And so x is on my x-axis, and y, of course, is on my y-axis. So when I plug in different values of x, and then it will churn out for me different values of y, and then I plot wherever those y values are, and then it gives me this beautiful red line, as we can see over here. So how do I use this graph to solve? So I'm going to hide that bottom bar away. Okay, how do I use this graph to solve this equation? What equation are we looking at? We're looking at this. Now this doesn't give me y equals to x squared plus 4x minus 21. It's saying I want x squared plus 4x minus 21 equals to 0. What does that mean? That actually means, in this case, this actually means that y must be 0, right? So it's quite simple actually. So I'm just saying that I want my values for this graph, I want it where y equals to 0. So where does y equal 0? Equals 0 here, right? Because so you look at the y, I can't really point digitally, but if you look at the y-axis, y equals to, from the top, 40, 30, 20, 10, then y equals to 0. And so Desmos has very nicely highlighted this point. Y equals to 0, and when y equals to 0, x equals to 3. Yeah, and then does y equals to 0 at another point? Yes. So let's go over here. When y equals to 0, x equals to -7. Wow. See, that's exactly what the solutions that we had previously, right? 3x equals to 3 and x equals to -7. And so we actually, what are we looking at when we look at these points where the graph cuts the x-axis? We're actually looking at the x-intercepts, where it cuts the x-axis. So you don't have to just memorize. Basically, the key point that you should know is that when you're looking at this at the top here, when you're looking at this equation, what you're really doing is you're plotting this, finding that whole line, and then you're letting y equals to 0. And when y equals to 0, you're actually looking at the x-intercepts. There you go.